Welcome to everybody. For any questions, people can ask in the chat. And also welcome for this session on linked list. So what are linked list? Linked lists are a sequence of data structures where each data structure has a reference to the next data structure. And this is very flexible because we can add elements in the lists, delete elements, and even the usage of the memory is more efficient than using arrays in certain situations. So the size of a linked list is not predefined, but it can grow or shrink during the program execution. These are some of the advantages of using linked list. So first of all, let's start a bit of exercise and see how all this works. Great. Let's define an array, and this array will contain integers. And it will hold 3 integers. And I'm going to initialize this array. And let's loop through this array and display the content. For I is equal to 0, I lesser than 3, I plus plus, then let's print the content of the array. I'm going to include the standard input output library. Great. Now the next step is to compile this code and see what happens and if everything goes right. gcc.main.c, the output file name will be main. Great. So this program will loop through this array and display the values in the array. This is because when you're using an array, all the values are contiguous in the memory. So in order to know the address of the next elements, you just have to add up 1 to the address of the current elements. So this is basically how we can loop through arrays. Similarly, we can loop through linked list by knowing the reference. Since we can loop through linked list, um, if you know a data item in the list, since that each data item hold a reference to the next data item, then we can use that reference to jump to the next data item. The elements in the linked list are not contiguous. So this is the way we use, for example, when you want to loop through from the start to the end of the list, you jump from reference to reference so to get access to each of the data items. So for now, let's create a linked list and see how it works. We have to first define a data item, a structure that represents an item in the list. So for that, I'm going to delete these things. Let's create a struct. And in that struct, we're going to call this data. A data item holds a value. For now, we're going to say it has a value. and it holds a reference to the next data item or the next sibling. But for that, we say struct data item. It will be a pointer, this field. So next data item. Great. Now we have defined the basic structure. This is the structure of an elements in a list. Each element has a value and also has a reference to the next data item. Now let's see how all these things work. We're going to create the data items manually, then we're going to connect them manually, then loop through each of them and see how it works. First, I'm going to declare create a type aliases because it's not always easy to type struct data item. What we're going to do, we're going to define a type aliases for struct data item. And the name of the aliases will be data item type. Great. Now, what we are going to do is that we declare a data item and a data item type. So we're going to call it item one. So the first, let's say, first item. So the first item is a data item, and we're going to initialize its values. So the value will be 10, and the next data item address will be null. I'm going to change the notation here, the names of the variables, so it become much easier for us to understand. Data item, data item type. And here also, we're going to call it data item type. Great. So we have the first item, which is of type data item type. And now we initialize the field to data items. So the next data item, this is a reference to the next data item. For now, it's null. Now let's create a second data item. The second item will be holding the value 5 and also hold the address to the next data item. For the moment, it's null. And let's create a third data item. So the third item will hold the value 3, and it also holds the reference to the next data item. So for now, the first, the second, and the third, they are not connected. So we're going to connect them. The first item will hold a reference to the next item. So that will be that. And the second item will hold a reference to the third item. And the third item doesn't hold a reference to any other item. So the first item, the third item is the last item in the list. So now we have connected these elements, so now they can make up our list. So how to navigate from the first item to the third item? It's simple, it's easy, because when you know the first item, and from the third item you have the reference to the next item, and from the next item you also have the reference to the other next item, and at the end the last item will have null as next data item because it is the last, there is no other after that. Now let's loop through this and see how things works. I'm going to declare a variable called data item, and it will be called the current item. The current item will be set to the first item. So while the current item we're going to make it a pointer, because when you are looping through a linked list, it's good to use pointers and practical. So for this example, we're going to use pointer on the first data item. So while the current item is different than null, so we can display the value. So current item, since you see the pointer, a pointer on a structure, we use the arrow operator to access the member field. So we use arrow, then value. Then after that, the current item, we have to move to the next item. For a list, a linked list, we use the reference of the next item. So the next item become the current item. So current item is equal to current item next data item. So now the current item become the next item and the loop goes. So this is how we loop through a linked list. A linked list is just a list of data structure where each data structure has a reference to the next. We cannot use indexes here because the data elements are not uh, located, they are not contiguous in the memory, so they can be spared around your memories. Let's compile this code and see what we'll get. GCC main.c, the O option, then main. It wasn't saved. Let's compile it again. And here it is, 10, 5, and 3. So someone asked if we can use dot notation in that loop. Yes, we can use dot notation. But if we use dot notation here, for example, it's easier to loop using the current item should be a pointer. That is one thing to know. And also, if you want to use dot notation, we can only add parentheses around and use the dot. So we use the dereferencing operator. Then after that, we use the dot. But it's more practical to use the arrow notation when you're dealing with pointers on structures. Great. So here, this thing we created, we created our data items manually, and in a normal situation, you might have a function that creates that data item for you, and also another function that links, um, that add, that connect those different data items together. So for now, I'm going to repeat we created a first data item, which is a structure, and we create a second data item, a third data item. None of these data item had a reference to the next data item. So then we proceed to connect these data items one by one. And the last data item does not hold a reference because there's no other after the third data item. And after that, we created a pointer that referenced the third data item. And we use this pointer to jump from one data item to another data item using the addresses. So while the current item is different than null, meaning that the address is different than null, we display the value of the current item, then the current item become the next item. So we use the reference to the next item in order to move from one position from one structure to another data structure. So there are multiple ways of doing this. We can use for loops. Someone asked that. Let's use a for loop to see what happened. For example, we can say um, for current item is equal to first item, and the current item is different than null, then the current item is equal to the current item next data item. Then after that, we display the value. This also is possible. And that's it. Uh, I prefer to use the arrow notation or the arrow operator to access the member of each items, since we're dealing with structure, pointers on structures. Let's compile this code and see what happened. Yeah, there is a semicolon missing here, and it will produce the same result. So we hold the pointer and we use that pointer to store the address of the data structures one by one. Since each data structure holds a reference to the next data structure, we can use the pointer to loop through the list. Great. Now, what is the next step? Let's delete all this. And also, let's make the things a bit simpler. We're going to have a function that will create dynamically our data items, and another function that will connect the data items. So let's do that. So this function, since it will create a data item dynamically, it will return the address to that data item. So we call it create item, and it will receive the value of that new data item. We have to include the standard in the standard library. So next we have a data item type, new item. Then we're going to allocate a memory location for our new items. So data item type. Then after that, we must make sure that the memory has been allocated. So if this is equal to null, we have to return null value. That means something goes wrong. But in other case, we're just going to initialize the field of this new data item. So the value will be set to the value we pass to the function. And since it is a new data item, it doesn't hold a reference to any next data item. So we're going to say the next data item will be equal to null. And after that, we are able to return the new item. Great. So we have now a function that creates a data item knowing that we have a value. So what if we want to uh, add a data item to something like a list? Let's create a pointer. This pointer will hold the first data item in the list of our data items. So let's call it data item. It will be of data item type, and that will hold a reference to the first one. Great. So now how do we connect? So we can just say the first item is equal to, we create a new item, and we say the value of this item will be 56. So we dynamically create this data item and it will be returned. Now let's create another data item and we call it second data item. Let's say this will hold the value 10, and let's create a third data item and this will hold the value 12. Yes, here we have to also specify the type. It is a pointer to a data item. So we have now the first, the second, and the third, but they are not connected. We can make sure they are connected. So we only do something like third data item is equal to the third data item next data item is equal to second item, and the second item will hold a reference to the third item. And the third item doesn't hold a reference to any other item. So the next data item for the third item is null. And still we can display um, this, we can display our data items. So we used a while loop to display it here, but let's create a function that will allow us to print um, our list starting from the first item. I'm gonna call it print items. Someone asked the question and we're going to read and see how to answer. Yeah, someone asked that uh, if we have to add, does it means, or it's asking, he's asking that uh, should we always declare a pointer in order to create linked list? Yes, in order to have linked list, at least uh, inside the data item, the structure of the elements in the list, we have to have a field that is of type of a pointer type. So the idea is that each elements in the list should hold a reference to the next elements. So uh, so basically, if you want to connect different elements, you would have to use their address. And since you can also create elements dynamically, that means also what happened, you can use a pointer to loop through the list. So in some sense, yes, it's always, I think if you want to use linked list, you always have to use, you have to always dynamically create elements. So you're always dealing with pointers. So the first element should always uh, can always be a pointer, but it's not required, but it's good that the first element be a pointer because your list might be empty. For example, if you have an empty list, there is no first elements. So if you declare you do not declare it as a pointer, that means whenever you declare a list, there is always one element in the list. And this is kind of um, contractor, this is kind of not good uh, because whenever you declare a list, you should always have a first element in the list. The idea is that a list can be empty. There could be no first element in the list. So you should always use a pointer for the first element. So you can point to, you can dynamically create the first, the second, and the third elements as you wish. That was a long answer. I was trying to find the correct words. Now let's uh, create a function that will print the item in the list. And this function will receive a, an address to a data item type. So it could be any data items, but this function will just receive a data item and then it will display the content of the data item and loop through the list. So first of all, we're going to have while item is different than null, and we have to print the item, the value of the item. So each item hold a value. So item, we display the value. And the current item will become the next item. So this is basically how we look through a list. We know the address of one of the elements, and we can use the references to the next elements in order to display values one by one. Great. Now let's use the print items function in our code here. So we pass in the first item. I'm going to compile this code and see. And yes, starting from the first item, it displays 56, 10, and 15. You can even pass, for example, the second item, and it will start from the second item. And since it holds the reference to the next item, it will just loop and display 10 and 15. So we can only move for the singly linked list, we can only move forward. So starting from a node in the list, we can only move to the end of the list, but we can't move backward for singly linked list. But we can make a ways that uh, we can change the structure in a way we can also move backward by simply adding another field that refer to the previous elements in the list. But for now, let's just keep up with the single linked list. So we can even print the list starting from the third item. And the third item is displayed 15. Since there is no other next item, and it won't display anything after that. So this is the idea. Each structure has a reference or hold a reference to the next structure in the memory. Now, this is a way we connected the elements one by one, but this is also not very convenient because you don't want to declare the elements in the list and connect them manually like that. You might want to create a function that will do this for you. So there is one thing to understand is that what we call the first item is actually there is another term we apply. We call this the head of the list, or yeah, the first element the list is what we call the head of the list. So whenever you hear head or first elements of the list, it's the same. It's referring to the first item in the list. Now I'm going to delete all this. And now let's create a function that will, we have a function that prints the elements of the list from the start from the first element. Now we're going to create a function that will append an element to starting from the first element. So we have void, then we call this function append. Then we'll pass a reference to um, the first data item. It will be a pointer on a pointer. We're going to explain what it is. Then we pass in the value we want to add in the list. Great. So what is next? The next thing is how are we going to call this append function? The append function will take the value and create an item, then add it to the list starting from the first item. So why do we use a pointer on a pointer? Because we want to be able to change the value of this variable from this function. So in order to do that, we do something like we pass in the address of the first item and then the value we want to append to our list. So this is how we're going to call this append function. It takes the first element, then appends a value or create a data item, then appends value to the list. So the appended value will be at the end of the list. So it will be the new um, uh, back in the list. So we declare a variable called data item type new item, and we call the create item function with the value. So this will return an item, and we also have to make sure the item is not null. So if it is null, we cannot add an item to the list. So we just call the return function. Someone asked the question about why are we using a pointer to a pointer instead of a single pointer. We're going to get back to that. Let's first continue, and I hope you're going to understand why. So we created a data item. This is the new item, and we assign it in to this variable. We have to check if the new item is not null.